Welcome back, everybody. It's now time to talk about one of our favorite topics, virtualization. To get us started, let's take a look at a very popular definition. And this is a reasonable definition. The only thing that I'm not real fond of is that it uses the word virtual in the definition of virtualization. For us, what we're going to consider to be a big part of virtualization is the idea that you're going to create more than one instance of an operating system on the same machine or the same set of physical hardware. Now, historically, we've had to create, or we've had a desire to create boundaries on machines. And the whole reason that we do this is so that the individual entities that happen to be running on the machine can each run independently. Otherwise, you'd have to do everything in a serial fashion. So we've got to figure out a way to share resources, processor, memory, and still be able to isolate those things from each other. We really don't want processes bothering each other. Now, it still happens, right? Because you are sharing the same physical box. The processor has to take turns handling things. You've got reads and writes from memory. So in this case, sharing is very generous in the sense that you've got a lot of physical hardware that you've got to divide up between these different entities that need to use it. But we also want to create some isolation by way of the process IDs so that we can shut one down, start one up without interfering with the other ones that are running. So we have this illusion that each application has the machine to itself. Because for that instant in time, an application is using the resources itself. But then some other resource steps in there. So even in the case where you take a look at the processes that are running on your machine, and you see there's 50 processes running there, there's got to be some way to share the resources, but separate the individual processes from each other. And an individual process might have priority over another one, and so rise to the front of the queue, do what it needs to do, and then step back. Now, in a case like this, because there's so much in the way of resources that are shared, we consider that this is very weak isolation because they're all in the same box. And even though we have processes and they're not supposed to step on each other, we've all experienced that case where one application all of a sudden starts to use a lot of resources. The one that jumps to my mind right now is any video rendering that you're doing, or Firefox. Firefox will sometimes just take off and use almost all of the memory on my machine. So let's run through a couple of scenarios. Let's think about a single user sitting in front of a machine, and that user has a bunch of applications open up. So in the bottom left, you can see that this is just my machine, and I've got mail open, I've got FTP open, I've got a browser open. And so how do these applications work together? Well, if you remember back to your protocols, we open up TCP or UDP sockets, IP address pairs, and port pairs. And that's how we identify the transmissions. Each one of the applications also has a process ID. The applications themselves don't share too much in between, right? They're separated, but they are still very much sharing the network connection and the processing and the memory on my machine. But now let's get multiple users. So we put multiple users, and in this case we're talking about multiple machines, and each one of those users might have multiple applications. And again, how much do they share? Not a whole lot. They might get to the same destination. They might be after the same server, but their individual machines don't have to share very much unless they're gaming together or swapping email or something like that. But even that hits a server and then down to the clients. On the individual machines, the applications still have individual sockets and processes, don't have to share very much between them. Well, let's look at this from the other side. What if I had a whole bunch of servers? So I've got either a bunch of web servers or a bunch of servers that are independent of each other, like in support of a VoIP implementation where you have FTP or TFTP, time servers, call servers, things of that sort, DHCP, DNS. How do those servers operate? Remember that when you have servers, you're dealing with server class machines, and that means beefy machines with lots of memory, lots of processing, and high-speed network connections. Well, now let's take all of these ideas together, and I tell you that you have to do all of those scenarios, multiple applications, multiple users, multiple servers, but you only have one physical machine to do it. How would you manage it? Well, you could allow a whole bunch of folks to connect to this one box on all the servers that it might be operating. Remember, you can operate a web server and a mail server on the same box. It's not recommended, but you could. Or we can introduce the idea of something called a hypervisor. Now, a hypervisor is the thing that allows us to create and use virtual machines on one physical box. There are two types of hypervisor. The type 1 is what we call a bare metal hypervisor. And we'll talk a little bit more about that here in a second, but basically what you're doing is you're minimizing the operating system that's actually running on the box and maximizing the resources that you can deliver to the virtual machines. A type 2 is a pretty standard OS like any of your Apple OS or Windows 7, Windows 8, Linux, and then on top of that, you're going to be able to run virtual machines. So you have what's called a host OS and the guest OSs, each sharing the resources of the physical machine. And this is what we commonly call desktop virtualization. So examples of bare metal hypervisor is EXXi or ESXi. And then we've got, for type 2s, we've got VMware Workstation and VirtualBox KVM, things like that. Okay, now another note here is that your hardware has to support virtualization as well. So hypervisors take the whole ideas of sharing and separation, and then they take them a little farther. Instead of just creating process IDs and sockets, you are setting up an operating system around whatever you're doing, and so you're creating another level of isolation. However, the virtual machines are now sharing the individual hardware boxes. So instead of having your applications share a box, now you have virtual machines sharing a box. So we still got to share the hardware or physical resources. Now, depending on what kind of hypervisor you're using, that varies the amount of resources used by the host. So a bare metal hypervisor like ESXi does not use very much memory at all. You can do the install on a USB stick. It takes a couple of seconds. It's not very heavyweight OS at all, which gives more resources to the VMs. In cases where the point of the box is to support virtual machines, one of the very important ideas is a virtual machine to physical ratio or virtual to physical ratio. And the idea is that you want to optimize or increase that ratio as much as possible. So these ratios here mean that you have 10 virtual machines running on a single machine, 20 virtual machines running on a virtual machine, and so on. Well, a very reasonable question to ask is, well, heck, what can I virtualize? Well, you can virtualize quite a number of things. You might just decide, well, listen, I'd like to play with Linux today instead of Windows 7. Well, in this case, you can do desktop virtualization and run a hypervisor and then start a virtual machine that would be running Linux. And that way you can go back and forth between your two windows, play with Windows when you need to, and then play with Linux to get used to it. So you install VMware or VirtualBox, and then you get the most common method is to get an ISO and then install the other operating system. In that example, Windows would be the host OS and Linux would be the guest OS. And again, that's desktop virtualization. And this is a simple example. This one here happens to be VMware Workstation. And this is my machine. And all I did was start up VMware Workstation. And you can actually get this via the MSDN Alliance. Installed Fedora 20 via an ISO and start up the virtual machine. So here you can see that in the background, I've got my host OS, Windows 7, and then my guest OS running there. And here we have another Type 2 hypervisor. This is VirtualBox. You can see that I spend a lot more time in VirtualBox than I do in VMware Workstation. because I've got along the left-hand side there a lot of VMs listed, and you can run several VMs at a time. Now, the more VMs you run, the more resources you're taking up, and so even a decent machine starts to bog down at 3 or 4 VMs running. Server virtualization is sort of the next step up from desktop virtualization. Remember that servers are often associated with server class machines. So anytime you have clients requesting data or information from a box, that box is usually a server. FTP server, web server, etc. Well, if your virtual machine is running a server, you could say that you're now doing server virtualization. But we gotta air this out a little bit, because you wouldn't normally want to do that in a case where you're doing simple desktop virtualization with a type 2 hypervisor. What you want to do is use a type 1 hypervisor and then set up a virtual machine that's dedicated to being that kind of server. So your type 1 hypervisor is running on a beefier machine, more solid, solid hardware, lots of memory, lots of processing, storage space somewhere. And then you install the server on that VM, and that's all that VM does. You're not running Microsoft products on that VM. You're not doing Office. You're not doing anything else but just the server. And this begs the question why you would need the host OS. And the only point of the host OS at that point is to provide service for the VMs. And that's why type 1 hypervisors are so lightweight. This is an example of a topology with a type 1 hypervisor. Now, along the left-hand side there, the switch that you see, vSwitch, is a virtual switch. And you can see that there's a router there, a Viata router, also a virtual network device. Toward the right-hand side, that's all physical hardware. Now, everything on the left-hand side there is running on one physical box. You can see along the left-hand side, there's a lot of VMs listed there and a lot of VM networks. So this gets also to not only the fact that we're running a type 1 hypervisor, that it is providing resources and physical presence to the VMs that might be running, but also the network virtualization that was emphasized in one of the papers. Well, other than being cool, why would you want to virtualize? There's almost no reason not to virtualize. There are an awful lot of advantages here, and we'll cover them here in a second. Remember that virtualization creates this separation between your hardware and software. And really what we're talking about now is a physical separation between the hardware and these instances of the OSs. And a really important part of this is this virtual to physical ratio. Now, we'll see here in a second that virtualization allows us to recover very, very, very quickly. And that's just one of the reasons that we virtualize things. Now, the reasons that you want to virtualize vary depending on what you're trying to do. So, for example, if I'm creating a bunch of servers, then my reason for virtualizing might be because I want to create dedicated operating systems to that particular service or server. Now, the really cool thing about virtualization is that once you get a server set up, so let's say that I'm setting up a web server, and I go through all of the things necessary to get that running. I install the operating system. I install the web server process or daemon that has to be running. And then I install my website, and then I set up all the database connectivity, and I set up all of the configuration files and all the data behind this web server. Well, if I was to lose the physical box, that would mean I have to do that all from scratch. But if I save it all in a virtual machine, the really nice thing about a virtual machine is that it is a single file. So now I did all of that, and I create a backup of the virtual machine. So now what happens if my virtual machine goes down? Well, I just start it up again someplace else with no loss. And the time that I was down is minimized. So backup and recovery of VMs is very, very easy. If you lose a VM, it does not mean necessarily that you've lost the physical box. In fact, if I've backed up my VM, so let's say that I'm dealing with a 20-to-1 ratio. I've got physical hardware that's running 20 virtual machines. And let's say that physical machine smokes. Well, if I've backed my virtual machines up off of that machine, the minute I get another physical hardware in there, I can start up all my virtual machines again. Now, the other nice thing about virtual machines is because we can do that, you can migrate virtual machines from one physical machine to another. If I had 20 servers and I needed to dedicate hardware to each one, I'd have to have 20 boxes. But in this way, I build one beefy box, maybe have a backup, and I spin up all my virtual machines on that. So I've got less hardware, I've got a smaller physical footprint. However, I do consume a lot of power with this. I'm going to build these bigger, beefier boxes. And they're probably more expensive than the individual boxes. All right, so I'm convinced I want to virtualize stuff. How am I going to use it? Well, we've already talked about server virtualization and what you can do, and that means any kind of server. But all of a sudden, now you're in this model of software as a service. You also have, with network virtualization, infrastructure as a service or platform as a service, because you can have a development environment. Now, this is the kind of idea that pushes us into the data center. The minute you're running services that people come to and you've got bigger, beefier boxes, maybe you're providing some storage, maybe you're providing an environment where you've got processing capability like a cluster, you're suddenly moving into this area of being a data center. Now, the data center is more than just beefy machines running servers that you're coming to. You got to figure out a way to create all of the storage arrays and then have folks accessing the storage. So now we've got virtual machines that are servers that folks are coming to. Now maybe we're going to store the data for folks once they've used our services. And then if we get really nutty, we might allow them to actually create their own virtual machines and we'll store them. So there's a lot of stuff that happens when you start talking about data center and a lot of ways that folks use them. So let's keep going with some of these ideas. We're using Genie right now. Well, you guys created virtual machines on Genie to run your tutorials. So Genie gave you the resources to create VMs. They had to store those VMs temporarily for you. They had to provide processing resources for your VMs. And then those VMs were networked for you based on the connections that you required at the time that you set up your VMs. So Genie provided a whole bunch of virtualized resources for you. And so we're starting to get into this idea of network virtualization. We also read a paper on mobile cloud computing and how applications are touching servers and services and storing data from mobile devices. Well, we already mentioned virtualizing network services. So I keep using the example of a web server, but there's nothing at all that says I can't virtualize a DHCP server. And the list goes on and on. We've got high performance computing clusters, gaming, all kinds of hosting services. Now, depending on how you're using the virtualized, or what we might even now start to call cloud resources in our data center, we are going to build the data center in such a way that we can handle the types of requests that we're interested in. Now, things like IBM Blade Center and all that stuff allows you to add and subtract the kinds of nodes that you want to as you go. So if I have lots and lots of VMs running, I've got lots of users and I'm allowing them to create their own desktop environments, then I've got a scaling issue. If I want to make sure that I've got secure infrastructure and that I'm creating the proper isolation between users, between groups, I've got to deal with lots and lots of policy. Maybe folks are coming to my data center because they want to chunk through data. So now I've got to deal with the demand for raw processing power. Now, no matter what you do, all of this stuff is going to take lots and lots of memory, and in all probability, lots and lots of storage as well. By memory here, I mean RAM. So the data centers, as we talk about them, there's definitely a lot of sharing there, right? You've got this big physical hardware, and you've got all the VMs running on the hardware. Maybe they're coming there because they're sharing the storage. So we've got a lot of sharing there, but you've got some significant isolation between the VMs. The VMs or groups of VMs should not be able to bother each other. If you go back to that picture that I showed you of ESXi running, VMs can be divided up into virtual networks. And remember that the VMs exist for a particular reason. So a fun question that I like to ask is, do my servers need to talk to each other? And it's just usually not the case. Web servers don't usually have to talk to print servers very often. Although I'm not going to say that there is an interaction between some types of servers. You might have a server that has to touch a database. So no conversation about virtualization would be complete without virtual desktop infrastructure. Now VDI is an architecture that allows you to do sort of remote desktop. So you can think to the Microsoft remote desktop connections. VDI is the production word for that. And a company that makes their bread and butter on this sort of thing is Citrix. So the idea is that you're running a VM somewhere, or you're running a machine that's hosted somewhere, and you are given remote access to that machine. Now this brings also to the conversation the idea of lightweight clients. If your desktop and your operating system are someplace else, how much of a machine do you actually need to get there? You probably need a minimal operating system and a network connection, and that's it. You can get your remote desktop connection or your virtual desktop, which resides elsewhere. So out of PC World, there was a nice list of all the things you can do with virtualization. We've talked about many of them already, but I wanted to mention some from their list. One of the fun things is that if you've got old applications or old games, you can spin them up in a VM. Remember, the VM is an instance of an OS, and there are not a lot of limitations as to what OS you can run. So you can run lots of old applications, and if you just can't live without your Windows XP, you can run Windows XP in a VM. We use virtual machines sometimes to take a look at malicious tools, data, or perform attacks. So if you spin up a machine, a virtual machine, and the virtual machine gets a virus or hits a website that is mining data or something of that sort, well, you can just shut down the virtual machine and the danger is gone. You can also test software and configuration. So let's say we'll just use the example of editing the registry. If I want to edit the registry and I do that on my host operating system and I screw that up, well, it's over. I got to do reinstalls or I got to undo what I did. But if I do that on a virtual machine, oh well, I kill the virtual machine and spin up another one. As I mentioned earlier, backing up a virtual machine is very easy. It's a single file. And so if you put all of your files in a virtual machine, you don't have to back up the individual files, you back up the virtual machine. Personal cloud computer, this is related to the virtual desktop infrastructure. You leave your machine at home. These days, we access machines remotely via tablets. And so sometimes it's a lot easier to carry around a tablet than it is your laptop computer or, of course, even the desktop computer. Now, when you run a virtual machine, if you're accessing something remotely via SSH or, God help you, Telnet, HTTPS, things like that, you don't need monitor, keyboard, and mouse on that machine if you're accessing it remotely. You just need to have this live VM out there. And so that is another advantage of having virtual machines. All right, gang, I think that'll about do it for our discussion on virtualization. I will see you guys next time.